Hey everyone. In today's lesson, we're going to take a look at how to find the inverse of a linear function. Okay, so you can see the inverse notation represented right here. It's f of -1 to the x, or the input of x is what I meant to say there. Find the inverse by replacing f of x with y. So the first thing I like to do is I like to rewrite anything I have wherever I have the function notation. I like to write with a single variable. Just makes the question a little bit easier to deal with. And then I'm going to isolate the other variable x, or our input x. After isolating x, we switch the positions of x and y and then write it using our inverse notation. Okay, we see an example of an inverse down here. If f of x is equal to 3x, then the inverse of that function, okay, would be 1/3 x. Just like when we talk about inverse operations, that's exactly what we're looking for. Here's pretty much the inverse operation of our function. So here we have multiplied by 3. Here it's almost like dividing by 3. All right, let's take a look at an example how to do one. Okay, so the first one we have is find the inverse of f of x equals -2x plus 1. So the first thing I want to do is rewrite it using, instead of f of x, I'm going to use y. So it would be y equals -2x plus 1. Okay, now I'm going to use inverse operations to solve for x. Okay, so I want to get x by itself. So I could subtract 1 on both sides to start. So I get y minus 1 is equal to -2x. Okay, I still want to get x by itself, so I'm going to divide by -2 on both sides. Okay, so what we end up with is x equals y minus 1 over -2. Okay, x is now by itself, so I'm going to actually switch the positions of x and y here. Okay, so now I'm going to rewrite this as y equals x minus 1 over -2. So you see how I switch the positions again of x and y. Okay, and we can rewrite this using our inverse function notation. So now it's going to be f -1 of x is equal to x minus 1 over -2. Now this one specifically could also, this is a totally acceptable answer right here. You could also rewrite it one more different way. We have f -1 of x, and it would just be like x over -2 plus 1/2. That's another acceptable answer. All I did there was I just split my terms being divided by -2. So that's also an acceptable way to write that one. Okay, give you guys a chance to take a look at that. All right, let's take a look at one more. Okay, so slightly different looking linear function. Same process though. So I have g of x. The first thing I want to do here is I'm going to again write it by substituting the y in for g of x. And then I want to solve for x. So I can start by multiplying by 2 on both sides. Okay, so I get 2y equals 7x plus 18. Subtract 18 on both sides, and I get 2y minus 18 equals 7x. X is almost by itself. The last thing I have to do is divide both sides by 7. And we get x is equal to 2y minus 18 over 7. Okay, so we have our x by itself now. Again, you need to switch the position of the x and the y. So now we're just going to rewrite this by switching the position here. I'm going to bring my work up here. So now it would be y equals 2x minus 18 over 7. And finally, we rewrite this using the inverse function notation. And there you have it. So that would be the inverse function of our initial. Okay, and again, you could also rewrite this as well if you want to break apart the fraction. This would be a totally acceptable answer, but if you want to break apart your fraction, you can also rewrite it just like this. Also acceptable. Okay, so there you have it. That's how you would solve for the inverse of a linear function.